All right, test 7 review. No calculator section. Number 1, simplify 5 squared root of 6 times 3 squared root of 40. When you multiply radicals, you multiply the outside 5 times 3. Keep it outside. Multiply the inside 6 times 40 is 240. Then you need to simplify. To simplify, we make the prime factorization tree. So doing what times what is 240. I could do 10 times 24. Lots of different things you could do. Keep breaking it down until you get prime numbers. So 10 is 2 times 5. Those are both prime. 24, I could do 3 times 8. 3 is prime. 2 times 4. And 2 times 2. Once everything's broken down, I'm going to rewrite this as 15 square root of all those prime numbers I have circled. So 2 times 5 times 3 times 2 times 2 times 2. Once I have everything in there inside the radical, when I simplify, I'm looking for twins. Twins can get out. So I have 1, 2 there and 1, 2 there. I circle the one that gets out, show that it gets out, and sacrifice the other twin. Got another pair of twins. One's out, one's sacrificed. So outside I have 15 times 2 times 2. Inside left over I have 5 times 3. Only thing left to do is simplify. 15 times 2 is 30, times 2 is 60. Inside 5 times 3 is 15. Number 2, which point appears to be a solution of both lines? So I put this on here because it can get confusing when we're talking about solutions. Solutions in the quadratic sense are the x-intercepts. When we're looking at a system, we have one or more equations. The solution to a system would be the point that they have in common. So that's the only solution. 3, negative 2. That's the only answer. Number 3, write a function that matches this table. So this function, we're looking at a function. The only 3 functions we do are linear, quadratic, or exponential. I'm going to check and see if it's linear first. If it's linear, it has a constant rate of change. So I'm looking at the outputs, the y values. Just going down 7, down 7, down 7. So it is linear. It does have a constant rate of change. So writing a function that matches that, I know that I'm going to have my slope as negative 7. I don't know what the b value is. It's where an x is 0. So I could go backwards and I could start right there and find when x is 0. If I went backwards, instead of subtracting 7, I would need to add 7 since I'm going in reverse. And that would tell me that when x is 0, y is 19. So that would be the entire function. Another way to do it, if you didn't understand the going backwards there, you could take any point and you could plug it in for x and y and then algebraically solve for b. So what I mean there is we're just replacing the y with a 5, x with a 2, and then actually do the math there, do the algebra and solve for b. Number 4, what is the vertex of the graph of that? So the vertex, this is the no calculator section. You do have the formula sheet. If you look on the formula sheet, here's the quadratic function. This is going to be handy for a couple questions here. If you ever forget to find how to find the vertex by hand, it is this part right here, the negative b divided by 2a. It's that part of the quadratic function. So to find the vertex, I'm doing negative b divided by 2a. That tells me the x value of the vertex. So here, a is 1, b is negative 10, c is 23. I plug that in, and I get x equals negative 10 divided by 2 times 1, 10 over 2. So x is 5. So the x value of the vertex is 5. That's going to be 5. To find the y value, I just need to plug in the 5 for every single x. So I would have 5 squared minus 10 times 5. Wrote that wrong. Plus 23. All right, doing that math, I'm going to get 25 minus 50 plus 23. 25 minus 50 is negative 25, plus 23 is negative 2. That is the vertex. Number 5, what are the solutions to that? So if I'm having to do this by hand without Desmos, you could factor it. A is greater than 1, so you could factor it and find the zeros that way. Or you could use the quadratic formula. So the quadratic formula, you would have to plug in everything back into this formula up here at the top. Let's try factoring it. To factor, I'm going to do A times C. I get negative 36. I'm looking for factors of 36 that would multiply, or that would add together to give me positive 5. That's those right there. Negative 4 times 9 is negative 36. Added together is positive 5, which is the B value. So what I'm going to do now is in the box, the first term 3x squared goes there. The last term negative 12 goes there. And then I split that B value using negative 4x and 9x. Take the GCF out of each row. That's 3x. That is negative 4 because it's touching a negative number. That would be positive x, and that would be positive 3 would be the greatest common factor. So factored form would be 3x minus 4 times x plus 3. I'm looking for the zeros and solutions, so to do that, I just set each of these parentheses equal to 0. Get 3x equals 4, divide by 3, divide by 3, x equals 4 over 3. That's the first x-intercept. The second one is negative 3. Those are the two x-intercepts. So pause this, see if you can do it without looking at my work, come back and check, see if you can do it. You could also use the quadratic formula. You should get the same answers. Okay, so hopefully you took the time to try that question. That is a challenging question with no calculator, whether it's by factoring or using the quadratic formula, but it's not impossible, so you can definitely do it. I'm going to erase this so I can look at the next one. Okay, this next question, number 6 here. This looks like a challenging question, but it's really not. What is the end behavior of the graph of f of x equals 5x squared minus 3x plus 11? So you could like find the vertex and you're going to get some decimals, and it's like you could do all that. However, what it's when you understand as x goes to the left and as x goes to the right, how do the y values end? So if you understand quadratics, let's look at just a basic graph. 5x squared minus 3x plus 11. It's probably going to look something like, I don't know, this maybe. But I do know that for sure the a value is positive. A is a positive number, so it's going to open up. Any parabola that opens up, doesn't matter where it is, its end behavior is the same. As x goes to the left, the y value ends going towards infinity. As x goes to the right, the y value ends by going to infinity. The y value is going up, both in the left and right directions. So this is just an if you had, which I think it is this on the test, so if you had a negative a value, if a was a negative number, understand that it's just opening down. So as x goes to the left, the y value is going down. As x goes to the right, the y value is going down. So it's really all you need to understand. You don't even need to do all that other complex stuff. Number 7, what is the solution to the following system? So this one is set up to make it pretty easy to do elimination. So when I do elimination, I'm trying to eliminate one of the variables, either the x's or the y's. So looking at this, I think it'd probably be easiest to eliminate the x's. And I can do that by creating an opposite pair. I'll multiply this bottom equation by negative 2. I get negative 2x minus 12y equals 22. I multiplied everything by negative 2. Now I can add these two equations together, and 2x plus negative 2x is 0. Those eliminate. Negative 4y plus negative 12y, negative 16y. 10 plus 22 is 32. Now I can solve for y. I can divide by negative 16, and I get y equals negative 2. That's the y value for the solution. To find the x value, I plug this y value in, and I can plug it in any of the spots for y, whichever one looks easiest to you. I would probably honestly use this one. I'm going to circle right there in pink. I'm going to use that one right there. I'm going to do x plus 6 times negative 2 equals negative 11. So I get x plus 6 times negative 2 is negative 12. Instead of x plus negative 12, I'm just going to write that as x minus 12. A little easier to see. Solving for x, I'm going to add 12, and I get x equals 1. So my solution, the x values first, and then the y value, 1, negative 2. All right, that's the end of the no calculator section. So for the rest of these, you can use a regular handheld calculator, and you can also use Desmos. So let's jump right in there. Number 1, a rectangle has a length of 17 meters and a width of 750 centimeters. So we got different measurements there. We got meters and centimeters. What is the perimeter in centimeters of the rectangle? Okay, so what I'm going to do first, I am going to draw a picture. I'm going to label, I'll label one side 17 meters and the other side 750 centimeters. Since it wants the perimeter in centimeters, I'm just going to go ahead and convert meters to centimeters. I'm going to go ahead and convert that side. I'm going to go 17 meters on bottom, centimeters on the top. 1 meter has 100 centimeters. You can see that is the same thing. It's equivalent to 1700 centimeters. I'm going to go ahead and label all the sides so that I can correctly do this. So when I find the perimeter, I'm adding up all the sides. So I'm doing 750 plus 750 plus 1700 plus 1700, and I get 4,900 centimeters. That's 34 plus 15. Yeah, 4,900 centimeters. And you could use a calculator for that. I just didn't have one handy. Number 2, what is the product of 3x plus 2 and 9x minus 7? So you got a keyword there. Your keyword is product. So for product, that means we are multiplying. When you multiply those, I use the box method. So I'm going to make a box. I'm going to put 3x and 2 and 9x and negative 7. Inside the box, I multiply. So top left, I've got 3 times 9 and x times x. So that's 27x squared. Bottom left, I've got 2 times 9x. That's 18x. Negative 21x, and that is negative 14. Last step, I write it out. I'm going to combine those like terms as I write it out. So 27x squared minus 3x minus 14. Which expression has the same value as the expression there? It's just being fancy, essentially telling you to simplify it by subtracting. So I have that minus that. I'm going to change that subtraction to addition. I'm going to distribute that negative to each term behind it. Now I can combine the like terms because I'm just adding. So I have 4x squared and negative 7x squared. Those combine to be negative 3x squared. I have 1x and 2x. And I have 7 and 5. 7 and positive 5. Those combine for positive 12. Number 4. For what values of x is the inequality 3 over 5 plus x over 5 greater than 3 true? Okay, if you have forgotten, when you are looking at fractions, you can add fractions if they have the same denominator, and those do. So what it looks like, if I add them, it's 3 plus x, the denominator doesn't change. Okay, that would be your first setup. I would write it out like that. Second step, solve for x. So get rid of your denominator first, multiply by 5, and then I'm going to have 3, it's not writing very well, hold on. 3 plus x is greater than 15. Now I'm going to subtract 3, and I get x is greater than 12. So for what values that is true, x can be anything that's greater than 12. Cannot equal 12, but anything that's larger than 12, that's what makes it true. Number 5, list 3 ordered pairs that are solutions of that. Okay, you could do this a few ways. I think on the test, let me pull it up, what it looks like. So on the test, it's multiple choice and it says which ordered pair is a solution. So if you had a list of points, you could plug it into Desmos and see which of those points is true, like plug in the points. You could also plug in the points for X and Y and see which one's true. But those are your options. So what I'm gonna do is I'm gonna plug it into Desmos. And when I plug it into Desmos, even though, let me show you, if I have negative 2y minus 6 equals 4x plus 3. Okay, line looks like that. So when you have it in this form, you can see if you click that settings that the table won't come up. It has to actually be in slope-intercept form. So if you're wanting to use Desmos for that, we're gonna actually have to solve it for y and get it by itself. So I'm gonna do that by adding 6, just getting y by itself. And I'm gonna divide by negative 2, divide everything by negative 2. I get y equals, that's negative 2x, and that would be negative 9 over 2. So now I'm going to type that in Desmos. Y equals negative 2x minus 9 over 2. Y equals negative 2x minus 9 divided by 2. Okay, that's what your line looks like. Here you can see the table. You can see all those are points. You could plug in any decimal. You could plug in any number and check and see what your points are. That's how it looks. So all of those are points. All of those would be true. All right, next. A shop sells 1 pound bag of peanuts for $3 and 3 pound bag of peanuts for $6. If 11 bags are purchased for $48, how many 3 pound bags were purchased? All right, I'm going to start by labeling my variables. This is a system. We have two different variables here. We have 1 pound bags and 3 pound bags. So I'm going to say that 1 pound bags, I'm going to say those are X. And 3 pound bags, I'm going to say those are Y. So I'm writing this out. If a 1 pound bag of peanuts is $3, that would be 3x. And a 3 pound bag is $6, 6y. The reason I'm adding them together is because it tells me I'm looking at the cost altogether. So if I had $3 per 1 pound bag plus $6 per 3 pound bag, I spend a total of $48. I don't know how many bags I bought though, individually. I do know that second part, that there are 11 bags purchased altogether. Doesn't matter what their price is. I just know if I add those bags together, however many I bought of each, altogether I bought 11. You could solve by elimination or you could use Desmos. I'll use Desmos. So I have 3x plus 6y equals 48, and I have x plus y equals 11. I'm looking at the point they have in common. That point is 6 comma 5. So that's the point they have in common. That's the solution, but that doesn't do us a whole lot because it has a specific question. You need to actually understand what that represents. And that is why I labeled those at the beginning over there, because it says how many 3 pound bags were purchased. So I'm looking at that Y value. So the answer is 5. 5 3 pound bags were purchased. Number 7, write a rule for the arithmetic sequence in slope-intercept form. Okay, so I know it's arithmetic. That means it adds or subtracts by the same amount. It's just like a linear function. It wants us to write it in slope-intercept form. So if I find the change in the output, it's going up 5 every time. That's just like your slope. And it's going, the input is also going up 1. So it's just 5 over 1 for your slope. So now I'm looking at 5x. The b value, all right, just like this one we talked about on the no calculator section. It's when the input is 0. So I'm looking when n is 0, what was that output? A couple ways you could do it. Again, just like on that no calculator section, if you watch that part, you could take any of these points and you could plug them in. That would be your input. So 2 and 3 would be your output. You could plug it in like that and solve for the b algebraically, or you could just use the same pattern and go backwards. Instead of doing plus 5, you could go minus 5, since it's just 1 away right there. That would be negative 7. So 5x plus negative 7, and we're at 5x minus 7. And you could always plug these numbers in to check them. So if you plug in a 5, you should get an 18. So if you plug in a 5 for the input and do 5 times 5 minus 7, you should get 18. All right, number 8. To rent a canoe, the cost is $5 for the oars and a life preserver, plus $12 an hour for the canoe. Draw a graph that models the cost of renting a canoe. So that would look like, if the cost is $5, that means, let's make our graph go up by 5. 10, 15, 20, 25. And let's make the x go up by 1. So if I'm going up by different amounts, I would need to label it so it's obvious where. The cost is $5, that means the y-intercept is $5, and then if it's $12 per hour, it means every hour it's going up by 12. So I'm going to go up to about 17, and then after 2 hours it would be 29 up there. So it would look like that. So when you're on the test, it has it's multiple choice, and the graphs are given. You're matching the graph to the situation. But understanding that if the cost is $5, that's your initial y-intercept, and then it's $12 an hour, that is your slope. So that's how much it's going up every 1 hour. Number 9, factor that. So this is where I keep putting these on these quizzes. This is a difference of squares setup. It makes it super easy to factor if you can recognize difference of squares. For difference of squares, both terms need to be perfect squares, and they also need to be subtracting. When you do that, I'm going to go ahead and write these parentheses. To factor it, the square root of the first term, 64x squared, that would be 8x. The square root of the second term, 144y squared. Square root of 144 is 12. Let me give myself a little bit more room. It's 12. The square root of y squared is y. So that's going to be my second term when it's factored. And then it's just going to be 8x plus 12y, 8x minus 12y. That is how you do difference of squares factoring. Way easier than having to do a times c. Can't even do a times c on this way. I think that's the reason it's set up this way. So you're having to recognize its difference of squares and what it looks like. All right, that expression represents the company's profit for selling X items. For which number of items sold is the company's profit equal to 0? All right, so we want to know when the profit, that is our output, or the y value. When is the y value equal to 0? That means we're looking for the zeros, the roots, the solutions. So you could use the quadratic formula. That one would be a big pain to factor, but I guess you probably could, but you could use the quadratic formula, or the easiest thing to do would just be to type it into Desmos. So that's what I'm going to do. So we've got negative 2x squared plus 80x minus 792. All right, if I'll do that, I can't see them, so I need to zoom out. There they are. So when x is 18 and 22, that is when the profit is equal to 0. Anything between 18 and 22, we have positive profit. Less than 82 and more than 22, we have negative profit. But right at 18 and 22, that is when we have 0 profit. That's when the y value is 0. So at 18 items and 22 items, we would have a 0 profit. What are the solutions to that equation? Okay, so that one would be kind of hard to use completing the square. It would be hard since the b value is odd. You're going to end up with decimals when you square it. So I'm not going to use difference of squares. Let's see. Let's just type it in Desmos. X squared minus 3x equals 18. Equals 18. Okay, let's zoom and find it. So if you type it in Desmos like this, you can keep zooming out. You'll see that you don't ever see a parabola. It's not a parabola shape. It's giving you the 2 zeros. The reason it's not a parabola shape is because it's not set equal to 0. You would need to actually do minus 18 right there. If you needed a parabola, it would look like that green one right there. But you can see it's still the same x-intercepts. So that's all it's asking for. You can see it's -3 and +6. Butterfly brackets around those. It's a list. Which explicit expression could be used to find the next term in this sequence? Here's my advice on this. It's multiple choice. Use your answers. This one's from the state of Georgia. It's if you can use some problem solving right here and understand this without actually deriving it, it would be way easier to do. So here's my suggestion. I would, if this is a sequence, that's the first number, 7. That's the second number, 16. That's the third number, 31. I'm going to stop right there. If I plug in a 1 for x, I should get a 7. So 2 times 1 squared plus 5. And I do, I get a 7. So that what that means, when you're using the answers, that means that could be the answer. Not that it necessarily is. We need to check the others. Let's plug in a 1 right there. 1 squared plus 6. That is also 7. So it could be B. 3 times 1 squared plus 4. That's also 7. This looks like a setup. All right, D. 1 squared plus 7. That would be 8. So with that, I can eliminate D. What I'm going to do next, I'm going to plug in the second number. So I'm putting in a 2 for the input. I'm going to replace these x's with a 2. I should get a 16. If I don't, then I can eliminate that answer. So I'm replacing the input with a 2. Okay, so I get, you type it in a calculator, be my suggestion here, 2 parentheses 2 squared plus 5. You get 13. That is not 16. We should be getting a 16. So now we can eliminate A. All right, here we got 2 squared plus 6. That's going to be 10. We can eliminate B. Let's check C, even though that's the only one left. Let's check it just to make sure we haven't done anything wrong. So 3 parentheses 2 squared plus 4. And you get 16. So it is C. That's how you can use your answers to input those values and check it instead of making it overly complicated. Number 13. All right, cafe's annual income depends on X, the number of customers. The function I describes the income. The function C describes the cost, the amount they spend. The profit is the difference between the income and the cost. So P of X, and this is true for business, your profit in a very general simplified form is whatever income you get, however much money you collect from people, and you have to take away what your costs were, how much money you spent for rent, to run the businesses, for employee salaries, things like that. So you take how much money you bring in, you subtract the cost, that shows your profit. So let's actually put these values in here. So the profit for X would be I is 5x squared minus 14x. Minus, I'm going to put parentheses around this whole C, since it's minus that whole C, that whole cost. So x squared plus 7 will look like that. Okay, I'm going to, just like we do a subtraction problem, I'm going to distribute this negative. So change it to addition. I've got to distribute it to each term behind it. Now I can combine like terms. So I have, change colors here. Let's go green. I have my x squareds. I have 5x squared plus negative 1x squared. I have negative 14x, and I have no other x's. So I'll just stay negative 14x. Then I have just one term left, negative 7. That would just be negative 7. So that function would represent the profit. 14. Flying disc is thrown into the air from a height of 6 feet at time t0. The function is modeled by that, where t is seconds and h is height. What value of t best describes the time when the disc is flying in the air? So what is the appropriate domain? So if I'm sketching a graph, it's going to look something like this, right? Let's pretend that's a good parabola. It starts at 6 feet, it goes up to its max height, and then it comes down. The quadratic function itself, that's annoying. Okay, the quadratic function itself has a domain of all real numbers. However, not for this situation. So you have to think about this actual situation, because it just says what best describes what values of t what domain describes when the disk is flying in the air. So from when you start, when you first throw it, all the way and boom, it hits the ground. Once it hits the ground, it's no longer flying in the air. Even though that line, if you put it on a graph, is going to keep going down, that means like if you're looking right here at this point, that means it's below ground, right? Your height, your y value is negative. We're not going below ground. It hits the ground right there at that second arrow. Okay, so that's what we're looking for. When did it start? When did it end? How long was it in the air? So let's use Desmos. Let's look at the zeros. Got negative 16. Remember, you have to use x on Desmos. If you have a variable like t, you have to just change that. So negative 16x squared plus 90x plus 6. Looks like, oh, messed that up. 90x plus 6. All right, so it looks like that. Apparently, we threw that really high, went up 132 feet. Then it comes crashing down pretty quick. So it's only in the air from 0 seconds to 5.691 seconds. Don't ignore that negative 0, because that would mean we went backwards in time. Like it started at 6 feet. It started at x is 0 at time 0. And then it goes up in the air, comes crashing down, and it's only in the air from 0 to 5.691. So x is greater than or equal to 0, but less than or equal to 5.691. That's your domain. 15. You got that function that models the height of a ball that was hit in the air, where t is measured in seconds and h is measured in feet. And then that table is a second ball. Approximately how long was the ball in the air for each function? So let's graph this first one. You got negative 16x squared plus 64x plus 5. Looks like that. So that one is in the air, again, starts at 5. It's in the air from 0 to 4.077. So f of t is 0 to 4.077 seconds. And g of t, looking at this table, so it starts at 0, and we have a height of 2 feet, and then it ends right there at 2, so it looks like that one is hard to see exactly when it hits the ground. That one is, we'll have to say, about 4 seconds. Which ball was initially thrown from a higher height? So our initial height is when x is 0, that y-intercept. So this function we've graphed, it's thrown from 5 feet. So f is 5 feet for the initial value when it's thrown. And g of t, the table, if we again look at that when x is 0, we can see that it's 2. So it's thrown from 2 feet. So the one that's higher would be f of t. Which ball reaches the highest maximum height? Okay, let's go back here. So this one, really threw that one high. That one gets up to 69 feet. So f of t gets to 69 feet. And g of t, the table, the highest we get for that y value would be 9. So it would also be f right there. Okay, 16. Which function in that form, let me pull up what it looks like on the test so I can give you good advice. So it has you, okay, okay, so it's multiple choice. This one's not too hard. So A we'll put as our initial value. B is the rate it's multiplying by. So our initial value, right there, the first one would be 10. The rate it's multiplying by, this one's kind of hard to just tell. But what we could do is go backwards. So to find that rate, take any number, divide the one before it, and we should be getting 2.5. We could check that again. So I'm going to take 62.5. I'm going to divide the number that's right before it, which is 25. I'm going backwards there. That shows me the rate. And I need to double check and make sure I get 2.5 to make sure I'm doing it correctly. And I do. So my rate, these are multiplying by 2.5. That's how you find that rate. So going back, give myself some more room. The initial value is 10. The rate it's multiplying by is 2.5. and then we can just leave that x minus 1. I think actually we probably should have said n minus 1 since it's using n, but you guys get the picture. And that is 2.5, not 2 times 5. 17. The function f of x is graphed below. With sketch a graph that shows f of x minus 3. All right, so if this is f of x, it's exponential. It has an asymptote right there at x equals 1. If we do f of x minus 3, we are just shifting everything down 3 because this is subtracting at the end. So that's moving it down 3. So if my asymptote was at x equals 1, I'm just going to move it 1, 2. I'm going to move it down 3. Now my asymptote is at f of x equals negative 2. That's my asymptote. And my curve, it's still the same curve. It's just been, I wasn't very good. Let's try that again. Still the same curve. It's just been moved down 3. That's a little bit better. All right, consider that pattern which recursive formula. So you have that recursive formula on your formula sheet. Look at that formula sheet, use that for the recursive formula. This hopefully should be pretty easy. We just need to find whether it's arithmetic or geometric. So if I'm looking at this, we have 1 dot, 3 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. 1, 3, 9. I should be able to tell that's an exponential function because it's multiplying. We have a rate. So the recursive formula is just simply going to be, I'll use the n. A_n equals the rate times a n minus 1. That's it. I do think on the test also it says like A1. So I'm looking at A1. A1 is just however many in the first part of the sequence. So I'm looking there. A1 on this example is 1. 19. The population of rabbits triples every year. Initially there were 8 rabbits. The function was created to model population growth. Y, where x is the time in years. The graph is shown. What is the range? So it's tempting to say y is greater than 0. You can see the asymptote's at 0, but that's wrong. It's wrong. Because initially there were 8 rabbits. We're looking at when time is 0. We're not going backwards in time. So starting when time is 0. So we start at 8 rabbits. And then it triples every year. So we go 24, what is that, 72, and so on. So what is the range that represents that? Well, the range, y could be anything greater than or equal to 8. However, there's a caveat. It does need to be any whole number, because we're talking about animals here. So any whole number greater than or equal to 8. Because, I mean, we could have 8 because we initially started with 8, so that's part of the range. Started at 8 and it goes on. We do need to say any whole number though, because we're not talking about like half rabbits or 0.3 rabbits. We are looking at whole rabbits. All right, almost done, getting closer. Write the equation that represents this graph. You can see it's an exponential curve. Hopefully you're familiar with this after all this comparison we've done. A times b to the x. A is the initial value, so 2. All right, that b, that rate it's multiplying by. Here's my advice. Write out some points so you can kind of see it, or even make a table. I'm gonna make an XY table. I'm gonna plot these points. That first point I've already done in purple right there, that x is 0, y is 2. This next point, x is y, x is 1, y is 4. This next point, x is 2, y is 8. So I can see the rate that it's multiplying by is times 2. So that's the rate. So it'll be written like that. I think that's it. Do remember, I'm pulling it up the test. The one on the test is a little bit more complex, but it's multiple choice, so you could type those into Desmos and match it. But do remember, like I think the one on the test, it looks like it has an asymptote. So remember that asymptote does add or subtract at the end. So that can help you there. Whatever if this asymptote, say that's 1, 2, you would have like plus 2 at the end. So The asymptote is what shifts it up and down, or how you can see it's been shifted up or down. Sketch a scatter plot that strongly represents a model of exponential growth. So, a scatter plot, I would want a curve, and they're not going to be in a straight line, but they are going to curve. They're starting to go up pretty quick. So if I had a line of best fit here, you can see the line of best fit would look like that. And it's not an undefined line. I can see that it is curving right there. So just recognizing scatter plots and which one would make an exponential curve. 22. Which function has a higher rate of change over the interval 0, 4? Okay. So we can't see where x is 0, but if I am looking at this, so if I look at g, it's plus 3, plus 3, plus 3, and this is plus 2, plus 2, plus 2. They're both linear. So linear has a constant rate of change, so I don't even really need to find what the rate of change would be since they're linear. This is going to always have a rate of change of 3. F is always going to have a rate of change of 2. So G is going to have that higher rate of change from 0 to 4. The one on the test is not linear though, but it's similar to the one that was on the last test where it has the two tables and it's saying like when does one exceed the other. So if you're looking at those intervals and like you could plot those points on a graph from the tables, because the one on the test is like it gives you two tables and it talks about like when does f of x exceed g of x. So it's just when does it take over a higher y value? That's what it's meaning. 23. If the parent function is f of x equals mx plus b, what is the value of the parameter m for the line passing through those points? It's just asking what's m, what's the slope. I would use the slope formula, y2 minus y1 over x2 minus x1. So I'm going to label that x1, y1, x2, y2, plug them in. I would have 1 minus 9 and 3 minus negative 3. I get negative 8 over 6, which simplifies to negative 4 over 3. That's it. What is the range of that graph? So if you did this question, you should get, let's see, let's graph it. Negative parentheses x plus 4 close parentheses. And let's put y equals, let's go home. It's just a straight line. The range is, the range of how it is right now is all real numbers. It was supposed to have, actually no, I'm looking at the test. I thought it was supposed to have a squared, but no, it's a straight line. So the range is all real numbers. You could also write that as negative infinity to infinity because that straight line goes up and down forever. Always goes up, always goes down. Has every possible y value there. Sketch a function that has a range of y is less than or equal to negative 1/2. Okay, so if y has to be less than or equal to negative 1/2, it cannot be linear because linear, all lines go up and down forever. If it's less than or equal to, that means it doesn't have an asymptote. That tells me it has to be quadratic. So if I was to sketch this, let's say that's negative 1, negative 2. If the range is less than or equal to negative 1/2, it means I have a vertex right there, negative 1/2, and then it's gonna go down. Never goes above negative 1/2. That would be how it looks. On the test, it's a similar type question, but it is multiple choice, so you could type those in and see how they look and just identify which one the range is greater than or less than whatever number it's giving you. All right, this is the last page. All right, last page. The graph shows the height of a rocket above sea level in terms of time t since it was launched. The rocket landed at sea level. What does the x-intercept represent in this situation? So there's our x-intercept. It's just represents when the rocket hit the ground. So it's when it has a height of 0 when the rocket hit the ground. I guess actually, technically it's not the ground. When the rocket, you could say, when the rocket returned to sea level, since the sea level is right there, what it's measuring. Just trying to word it how it is on the test. When the rocket returned to sea level, you get it though. It's when it hits the ground. It's when it's back to sea level. Should be easy. 27. School is having a canned food drive. The amount of cans are listed below. Which homeroom averaged more cans, and how many more did they average than the other? So when we're looking at average, we're finding the mean. So I'm going to use X bar to represent. So let's do the freshman. I'm going to add all those up and divide by how many there are. So I have 24 plus 18 plus 36 plus 48 plus 27 plus 13. And you do need to hit equals here. Get that sum. So it's 166. Because if you type all that out and do divided in the same one, it's going to divide by that last number and not do it correctly. So I get 3, 4, 5, 6. 166 divided by 6 is 27.67. Okay, let's do the sophomores. We have 26 plus 29, 33, 11, 47. I get 146 divided by 1, 2, 3, 4, 5, 6. And that is 24.3. So the freshmen had more. They had about, what is that, 2.33 more? No, 3.33, sorry, 3.33 more. 28. Math teacher recorded the test scores of each student in her class after the students completed the Delta Math. She displayed the results by class using the box plots shown. Which class period generally had the highest scores? So I'm looking at like their measures of center. If I'm looking at generally the highest, I'm looking at measures of center. What measures the center is the mean and the median. Box plots do show the median. So if I'm looking at medians, period 5 there at the top, they have about a 75. Period 4 has about a 60. Period 3 and 2 have about a 70. And then period 1 has about an, what was that, 88, 87, 88. So generally, first period there has the highest. Give a real world example of positive correlation, negative correlation, and causation. Okay, positive correlation. So, I mean, the easiest one is like as temperature goes up, ice cream sales go up. Like that's a, ice cream shops sell more ice cream whenever it's hotter. A negative correlation. We could look at, what would be a good negative correlation? I got a good one. The screen time on your phone and your test grade. So as your screen time goes up, as you spend more time on your phone, your test grades typically go down because you're spending less time either paying attention in class or studying or doing stuff you're supposed to. Is that true for every single one? No, but that's why it's a correlation, not a causation. So an example of causation. Causation is kind of a hard example. Hard things to think because it's like one thing directly causes another. So what we could say though is um, like let's think of, I don't know, a something that like sells something. So let's say a toy shop. As more toys are sold, the company collects more money. So every toy you sell, you get money for it. That's different than profit. Like it's just you collecting money. You have cost and whatnot if you're a business person. But like every toy you sell, you get money. Say each toy is $10. Every toy you sell, you collect $10 from someone. So as you sell more toys, those toys are causing you to get more money. Like you are getting more money directly because of those toys. It's not a relationship. It's like this one thing is directly causing the other. So good luck on your test. A little bit difficult, but it's the end of the year, so I'm sure you'll do fine, especially if you've watched this far and you guys have worked hard all year. Take your time, use your brain, use your resources, and do well.